There's this small example that I had last week. I'm going to write this down first, then it will relate to what we have today. Last week, we solved for a unknown that is, for example, in the P position. Your probability of success is unknown. And the question that may come with it could look something like that. They say less than or equals to 1, this probability could be 0.8. How did we solve for something like this? If the unknown is at the P position, you will use a GC and you will sketch this as the Y1 and this as the Y2 graph. Graphing calculator to put in this. And we will use graph to solve for the unknown P. It's graph because this is a value between 0 to 1. It is not a whole number. If it's whole number, as per what you have done in previous chapters, you will go for a table. Okay, the consideration is always graph or table. So we look at it from this perspective. I'm going to show you questions where we use a table instead of a graph. So where do we and how do we identify a table? In this particular setup, the distribution values are all known. The unknown value that you want to find, which is A, is occurring at this particular position. Px lesser than or equals to A is more than 0.7. And at this position for a binomial, you will know that it's always an integer. So as long as you identify that it's an integer unknown value, you will go for GC with a table. So let's go through again. How did we generally go for a table? You will key in at your Y1 position, like your usual graph. It's less than or equal to in the problem, so we aim for binom CTF. After you put in, they will ask for Charles P. Remember, this is your X value. This X value is your A. This is the A that we want. This is the X value. And you paste it onto your graph. You have this. Go for table. You press second graph for a table. Now, what are we looking for? We are looking for the value that's larger than 0.7, which is occurring at 7. This is the first time that this is larger than 0.7. You can either do this, or I will also suggest that instead of checking against 0.7, you may want to just move everything to one side and key to the graphing calculator instead. Generally, for unknown values that are whole numbers, I prefer to check against 0. This is what I will be doing preferred, but both works. The logic is you just check for the inequality. But you also need to know how to present. Can I just use the last box there? Help me to construct in a table. When we present, there will be a table structure. You help me draw in 3 rows and 2 columns. Okay, I want a table to look something like this. It is also important for you to label the headers correctly. Do not just label as X and Y1 as per the graphing calculator. Label in context. What is X? X was finding the A value. So your top left should be A, not X. What did we key as Y1? I keyed this part as Y1. This was what I wanted. So you should write back the same thing with that unknown appearing. This is my Y1. The header must match the context information. You will write in the rows that resulted in that change in the inequality. So it's at 6 and 7. Because at 6, this number is lesser than 0.7. And at 7, this number is greater than 0.7. We show the 2 rows that resulted in the change of values. And therefore, your smallest possible value is at 7. Let's carry on to 12. Next one. We have got a binomial variable such that, again, this is the distribution. but we can immediately see that it's the n that is unknown, and this position again is an integer unknown. So integer unknowns in the context of a binomial variable is usually at the n or at the x value position, just these two. Can we find the largest value of n such that this equation must hold true? So again, we are going to key in the same thing, put it to the graph, binom CDF, but the difference is where the position of x is now placed at troughs. This troughs is actually your n, but we key in as x as the unknown. Okay, so once I paste it, what I would like to show you is the difference in the end result on the table. Let me just zoom in here on this table to show you. If you look closely on the left-hand side, when I keep scrolling down, the values don't seem to change. You want to know that you can jump faster. At this current moment, the jump is by 1. If I keep seeing the same value, it means that we have to jump a bigger gap each time. And to jump a bigger gap, what we can press is you can press plus. It's at the top on your GC also showing you and reminding you to press plus. I will key the value 10. When I press plus, I key the value 10, the table will now increment by 10 units each time on the left column. So you're going to see that on the next screen, that additional value is always a plus 10 when I jump from one term to the next. Yeah, so from here, I can identify where is it first more than 0.9 is at this particular number. It is more than 0.9. But it doesn't mean the answer is 63. What does this tell me? The answer here or the table here is showing the answer is between 63 to 73. It's within the zone that there will be a jump against 0.9. So you must go back and make the change become 1. 1 at that position of 63, move it back 63, change to plus 1, so that we pinpoint the exact position. Okay, and for us, fortunately, it's still at the value 63. This is the first time that or the last time that it's still larger than 0.9. After that, it will change. Okay, so you need to know this technique of trying to adjust your table quickly by going for this plus, okay, plus 10 or plus 1 to jump.